Hey there guys, here we are going through a fairly tricky 4-mark circle theorem problem. Now it's a very circle theorem heavy circle theorem problem. We're going to be using lots of different theorems. So this comes as a request from one of my own minions. So Maddie, if you're watching this, hello, hope this helps. So A, B, C and D are points on the circumference of a circle. AC is a diameter and AT is a tangent. Our mission is to find the values of X and Y. So, let's zoom in a little bit then. So, X, first of all, is this chap here. Now, to find X, the two theorems that we are going to use, first of all, this guy on the left. So if you can see this sort of setup inside of a triangle, where you got two triangles connected and they are touching the circumference, top and bottom, and then the top two angles are equal and the bottom two angles are equal. This is called angles in the same segment. So, where does this pop up? Here. Well, roughly, we've got this situation going on like that. So that's going to tell us then that given this angle here is 30 degrees, that means this angle over here is also 30 degrees. Good times. Okay, next up. Now we know that AC is a diameter of the circle. So there is also a theorem about that, and that's this guy. So if you have two chords coming off of each end of a diameter and then meeting on the circumference, they meet at 90 degrees. So that tells us that this whole angle down here is 90 degrees. Now, what we have going on here is a right-angled triangle. Now we know angles in a triangle add up to 180. So now we know 30 add 90 add X is equal to 180. 30 add 90 is 120. 120 add X is 180. Therefore, X is 60. So we now know the value of X. Good times. So now we need to find the value of Y. Okay, so to find the value of Y, we're going to need another theorem, and that is this guy here on the left. That if we have an arrowhead going on inside of our circle, the angle at the centre is double the angle at the circumference. So let's see if we can spot that. So our arrowhead is this guy here. So if we can find the angle at the centre, then we can find the angle at the circumference. Now, at the centre, we've got this angle of 72 degrees. We know this is on a straight line with this other angle at the centre, angles on a straight line add up to 180. So this angle then is 108 degrees. So we know then that this angle at the tip of the arrow is 1/2 of 108, which is 54. Okay, now we know this whole angle down here at point B is a right angle, 90 degrees. So we can work out what the other part of the angle is by doing 90 minus 54, which is 36. Now, it's at this point where we could just use one more theorem and get our angle of y without any more calculations. I'm going to come back once I've done it the first way and then show you how we could have done it from this point. So, here then, in the bottom right, we are now in a triangle again, where we know two angles of 36 and 60 degrees. 36 add 60 is 96. So this angle here is 180, take 96, which is 84. Okay, then if we move up, we know angles on a straight line add up to 180. So that means this angle is 96. Okay, now again, we're inside a triangle where we know two of the angles. So we got 96 and 30. 96 add 30 is 126. So this angle down here is 180 minus 126, which is 54. Okay, now there's one last theorem that we need to get a y. And that is that a radius meets a tangent at 90 degrees. So, here we know this whole angle is 90 degrees. So, y then is 90 minus 54 degrees, which is 36 degrees. So there we go, we have our values of x and y. So now I'm going to go back and show you how we could have got the value of y a lot earlier. Okay, so it was at this point then where we had this angle of 36 degrees. Now there is a theorem that would have got us there from here. And that theorem is this guy. Now this guy is called the alternate segment theorem. Now this happens when you have a tangent to a circle which is attached to a triangle with three vertices on the circumference. So, what we can see here then, the angle top right on the tangent is equal to the left angle in the triangle, and the bottom left angle on the tangent is equal to the top angle inside of the triangle. This guy is called the alternate segment theorem. So, do we have this situation going on? Yes, we do. There's our triangle. So, we know that angle y is equal to this angle of 36 degrees. So that's another way that we could have found angle y. Okay guys, that's all the fun for this video. If you want more circle theorem content, check out my links down below in the description, where I'm putting all my circle theorems videos, including a PDF with all the circle theorems on it, which you can print off and whatever. Probably quite useful for revision. If anyone has any requests, let me know down below in the comments. For now, take it easy guys, take care.